The presented protocol helps to reduce the required time for fabrication and testing of microscale material specimens and provides clear guidance for the micromechanical testing of metal materials, which is applicable to many engineering fields.
This technique allows high-throughput fabrication and testing of microscale material coupons. Additionally, by creating microcolumns via photolithography, material reposition is reduced and micro-tensile grip maneuverability around the specimen is improved.
Although this method was applied to steel, similar methodology could be used for other materials, such as silicon, to improve the designs of microelectromechanical systems, or MEMS.
Wet etching and grip sample alignment are challenging steps. It is recommended to perform the wet etching with the sample warm. For improved alignment, use the microscope working distance or focus to verify that the sample is engaged.
Begin by cutting a section of 6 mm from the area of interest with a slow dicing saw or band saw. Using a semi-automatic polisher, start polishing the sample using a 400 grit abrasive paper by maintaining a flat surface. Then progressively move to 1 micrometer diamond particles, alternating the polishing direction by 90 degrees following each grit level. Then, use a slow-speed saw to align the material and cut it into a thin 0.5 to 1 mm section. Place the sample on the spin coater with the polished side up, and use compressed air to remove any dust or particle on the surface. Apply photoresist to the sample, and run the spin coater. After coating, heat the sample on a hot plate.